Colby, math.com.
Tonight's assignment is about circle graphs, but it's just as importantly about dealing with large numbers and understanding a bit of geometry about circles, but mostly dealing with large numbers and finding efficient ways to do computation when you're dealing with large numbers. We're going to do problem 2 together. First, I want to show you this website, census.gov/popclock/world, because the 7.2 billion figure that we're using in this problem for the world population is no longer accurate. If you go to that website, the world population is nearly 7.6 billion now, and the United States population is, looks like almost 330 million. If you hover over different countries, you can get their population and some other data. This could be useful for lots of classes. Okay, but if we use the figure 7.2 billion for the world population, how many people live in Europe? When we look at this circle graph, we see that Europe represents 12% of the world population, at least at the time this graph was made. And so in order to find how many people in Europe, we would need to find 12% of 7.2 billion. But let's talk about a billion. If I start with the ones, tens, and hundreds place, we know this would be the thousands. Thousands, 10,000s, 100,000s, this would be millions. Millions, 10 millions, 100 millions, and so a billion would be a 1 with 9 zeros. So 7.2 billion would be 7 followed by a 2 and then 8 zeros. If you go into auto mode now, some of you may be tempted to then represent 12% as 12 hundredths. Understand that this is multiplication. And then just go ahead and multiply, but I wouldn't recommend doing this, so don't write this part down. So many zeros, 8 zeros after that too. And that's why you don't want to do it this way. It's ridiculous to use the multiplication algorithm with this many zeros. There's lots of ways to make a mistake here. What's much better is to understand that this number, 12 hundredths, is literally 12 hundredths. 12 1/100ths, and this 7.2 billion figure is, let's just go ahead and write it, but it's clear that if I take 100th of this number, you can just knock off 2 zeros there. That's just taking 100 100ths out of that expression, and so now I have a 7 and a 2 followed by 6 zeros. Well, 6 zeros is a million. So I have 12 times 72 times a million. So if I just find this partial product, that's how many millions I have. And you could do 72 times 12 the traditional way, or you could just think of 12 as 10 and 2. 72 times, let me show it better though. 72 times 10 plus 2 is 72 multiplied by 12, and then I can distribute that factor to both terms, and 72 times 10 is 720, and 72 doubled is 144. So that's 864. So I have 864 times a million, or 864 million people. When you use the traditional algorithm for multiplication, when you do 2 times 2 is 4, 7 times 2 is 14, and then when we're multiplying by this 1, we're really multiplying by 10 because the 1's in the tens place, so we start with the 0 in the ones place, and 2 tens is 20, 70 tens is 700. All that algorithm does is just keep everything in the right place value, but when you see the two partial products we have here are the same as if we just did it using mental math. Okay, so that's the easy way to deal with large numbers. It's understanding representing the numbers in different forms and then associating to your advantage. What is the angle in degrees of the Oceania portion of this circle graph? And it says do not measure, so don't grab a protractor and start measuring it. It would be nearly impossible anyway, because you see that Oceania portion is such a small sliver, it would be nearly impossible to get an accurate measurement of how many degrees that piece of the circle graph is. But what you can do is think about finding 0.5% of the total number of degrees in a circle. And I hope you learned that during today's lesson, but if you didn't or you don't recall, please look that up during the pause and try to complete this one on your own.
Paused.
There are 360 degrees in a circle, so except that's not how degrees look. 1/2 of 1% of 360 degrees would be 5 thousandths. I just move to find a percent, move the decimal 2 places to the left, because percent is out of 100, so you're dividing by 100, multiplied by 360. You can do that traditional algorithm if you like. I don't think it's a terrible choice in this case, because we're just going to multiply 360 times 5 and get 1800 and realize we have 3 decimal places. So 1.8, I think that's just as efficient as the other thing I'm going to suggest, which is understanding that this is, if I start from here, 0.5 is half, so 1/2%, 1/2 hundredths of 360, and then I can associate the half and the 360 and get 180 hundredths, which would be 180 over 100, which will also give you 1.8. But in any case, 1.8 degrees will be the answer to number 2. I hope that helped with the homework. I'll see you tomorrow.